Hey, my name is Peter Enrico of Enterprise Performance Strategies, and my background is I've worked in mainframe computers since 1984, so for those of you who don't know, that's about, what is that, almost 40 years now. This would be my 40th year in the mainframe computing environment. I started out as a system programmer. I worked for IBM for many years as an RMF designer and developer, and I worked in workload manager algorithms for the first release of Workload Manager. I've done a lot of performance work, and I started my own company over 20 years ago, and I focus on ZOS performance and performance education and performance reporting. Well, my focus is on ZOS performance. So the performance projects that I work on with my clients is mostly about, transactional performance, making the customers happy. You want your workloads to perform well. It's about resource optimization because mainframes cost a lot of money, the software costs a lot of money, the resources cost a lot of money, so you want to get as much out of them as possible. And of course, MSU reduction to be able to reduce your software prices. And of course, the big challenge is getting all three of those objectives, workload performance, resource optimization, and MSU usage, to all sort of find the optimal point for all one of them. But they are conflicting objectives, so it's hard to do that. So the whole point of performance now is to find the right balance of all those three areas. Well, mainframe modernization, I'm not sure is a good term, I don't think, because there really is no concept of modernization. Mainframes have been modern since the day they came out. In 1964, they were modern for that time. In 1984, they were modern for that time. And I guess the main thing about today in terms of modernization is to make people realize that the mainframe is not a relic, is not old. It's not old technology. It is new technology. It's new technology that's been around for 40 years because it's been evolving for 40 years. So in terms of modernization of the mainframe, it's really about the modernization of a legacy platform to make it still viable in today's environment. The latest mainframe technologies, I think, everybody goes with the concept of AI, so of course artificial intelligence is a major thing, but that's going to be on all platforms. Mainframe is just going to be one of those platforms. And I think the main thing is, for modernization, is more or less making those who are interested in other platforms, like Windows, like Unix, like Linux, like other platforms, know that the mainframe is still a viable solution. So modernization is really making people understand that the mainframe is still viable today, is really what, to me, about mainframe modernization is. Whatever that takes, that's what it's about for me. The technical skills required for today, that's a tough one. I mean, there's always the skills, which is the basic skills, JCL and system programmer type stuff. But I really think it's about adapting to learn about the technology, meaning that the mainframe is not an isolated platform where you do have to integrate it with all the other platforms, whether it be the cloud, whether it be you're on site, whether it be you're communicating with Windows or other platforms. You have to be able to do that. So it really is about looking at cross-platform and how the mainframe fits in as part of that solution. What I would also recommend is that people don't pigeonhole themselves into one area. I mean, I always say people, learn about performance, learn about networking, learn about pricing, learn about maintenance, learn about security, and all of those together make a viable skill set for anybody who wants to know anything about mainframe computing. Yeah, so I kind of touched on that in my last question. I think to grow in your own career, I mean, my background is, my specialty is computer performance, and I kind of fell into that because I majored in mathematics in university. And so it was a natural fit for me to do that when I first joined IBM many years ago. And I worked on mainframe computer performance. And it's an interesting field because no matter what, you're always going to have computer problems, performance problems. There's always going to be the opportunity to optimize or make computer better. So my career kind of evolved in, I did development and design for a product called RMF, which is the resource monitoring facility, which is measuring the computers. I segued from that into what's called Workload Manager, which is the algorithms to optimize the usage of system resources and to help workloads meet their objectives in terms of performance. And then eventually I did a lot of performance work. And eventually when I left IBM, I formed my own company. And because my background was with performance, I kept on using that performance sort of background. In terms of the second part, which is, priming somebody else to do their career, it really is about learning different areas. You have to really not just learn how to, put the square peg in the square hole. You really have to kind of think about what you have to do in terms of thinking multidimensional. How does it satisfy the customer? How are the workloads being affected? How is my software bill going to be affected by changes that I do in performance? And so it's really about learning about the platform and what the customers expect, what your management expects, and what you should expect of yourself in terms of making the computers perform, do well. Well, what makes a project successful? That's an interesting question. I guess, again, my background is performance, so whatever makes projects successful would be, the transaction running faster, maybe using less CPU, getting more out of the machine. I mean, we've done many exercises with customers where one little change can make an enormous impact into the performance of the workload or save an enormous amount of CPU, and it's those discoveries that really make my job very interesting. So we do that a lot. We don't always find those golden nuggets, but we do make incremental changes, and it's nice when you get a customer saying, hey, that was a great change that we made. It made a big positive difference, or the presentation you gave me really gave me some insights I never really understood. So that kind of thing is interesting for me. Picture you have your bedroom, your room, and in the room is lots and lots and lots of different toys. And you want to play with all of them. You have the big toys, you have the small toys, you have the ones that maybe you're reading a book, you're doing all these things. What's interesting about mainframes is it's like your bedroom, and you have all these different toys, meaning all these different workloads, all these different things that you want to do. And the mainframe, you're able to do them. When you think about the toys in your room, you think about, I have my dolls, I have my books, I have my coloring books, I have my Barbie doll sets, or maybe my Tonka trucks, and there's all these different toys that I want to be able to work with in my room. And what's interesting about the mainframe is we have different workloads, different things we want to do that the customers want to do that are like your toys in your room. They're so different, but it all works, it all happens. And even though it's one room with all your toys, you're able to play with all of them, and we can make it work. So what I would want clients to know more about the mainframe. So first of all, the answer is really nothing, because my clients are already mainframe people. So that's not really the issue. I can tell them a lot about computers, I can tell them a lot about the mainframe, but to be fair and honest, they already know a lot. They already know the basic concepts. I think the more interesting question for me would be, what do I need to tell people who are not mainframe people about the mainframe? And I guess the main thing I would say about the mainframe is kind of what I started out with, is the mainframe is not a relic. It is something that is as modern as today. In today's day and age, people think of the common things of Windows and Unix and Linux, where the mainframe, oh, it's old, it's legacy. And I went to a presentation recently, and I think the person pointed out that legacy is a horrible word to describe the mainframe. A better word to describe the mainframe would be legendary. Because when you really think about it, it really is 40 years old, or 60 years old, and in 60 years, it's as relevant today. You are not going to run a huge bank, you're not going to run a huge financial institution, you're not going to run a huge corporation, whatever it may be, with a Windows computer tied together, or a bunch of Linux servers and things like that. The mainframe is the powerhouse behind all computing for the big corporations. And so what I would say to you is the mainframe is not old, but you can think of it as not being a relic, but it's being a powerhouse of computing. That's what I would say. Oh, well, with our workshops, what's interesting about our workshops is we always ask for a set of data before the workshop. So our students will send us SMF data, for example, and tell us about their environment. And then during the class, we are teaching about, in this case, parallel sysplex, data sharing, coupling facility, but all the exercises are with their own data. So we always advertise to say, not only are you going to learn about the subject matter, but you will be doing an exercise of your own environment. You will be leaving with recommendations, you will be leaving having looked at your environment, and you will know something more about your environment. Even if you don't change anything, you're going to know something more about your environment and how it works.